Troubleshooting is one of the most difficult things to learn and teach. By its very nature, troubleshooting is a very complex task. It isn't as simple as looking up a symptom and then finding the solution. Good troubleshooting skills come with experience. However, most good troubleshooters follow a structured process that helps them identify and resolve the problem without causing additional problems. First, begin by identifying the problem. This is a very important step. Don't be too focused on immediately solving the problem. You could actually cause more problems than you solve if you do so. Instead, you should first take the time necessary to gather as much information as possible. This helps you develop a more complete picture of the problem. You should gather as much information as possible by doing the following. Question users to identify the exact symptoms they have experienced. Identify the scope of the problem. Is the problem isolated to just one user, or are several users having the same problem? Is the problem on a certain network segment, or is it the entire network affected? Determine if anything has changed in the environment. Many times, problems end up being caused by changes that were recently made in the network. For example, you could check to see whether new hardware or software has been installed. You could also determine whether the affected computer moved from one location to another. Duplicate the problem, if possible. See if you can reproduce what the user is experiencing. At this point, you may determine that more than one problem has occurred. If this is the case, be sure to approach each problem individually. Don't try to develop a universal solution for all of the problems at the same time. After concretely identifying the problem, you should next establish a theory of probable cause. To do this, review the symptoms and determine the most likely cause of the problem. As you do, be sure to question the obvious. This is important because you might be tempted to look for obscure causes to the problem. This isn't a good practice. Instead, you should begin by looking at things that commonly go wrong. This is called questioning the obvious. You also might focus on things that are easy to try and that might result in a positive solution. For example, you might check the condition of a network cable before you replace the computer's network board. As you try to establish a theory of probable causes for network issues, be sure to consider multiple approaches. Analyze the problem within the context of how data flows through the OSI model. A data transmission starts at the top of the OSI model on the sending host, is processed down through the OSI model on the sending host, travels across the network medium, and is processed up through the OSI model on the receiving host. You can also use a process called divide and conquer to isolate the fault domain where the problem exists. This narrows your efforts to a specific part of the network. Once you've established a theory of probable cause, you next need to test your theory to determine whether it's correct or not. This is a very important step. You should not attempt to implement a fix until you are as sure of the cause of the problem as possible. If your theory is confirmed, determine the steps required to resolve the problem. The internet is probably the best resource you have at your disposal. If you're experiencing a particular issue, then it's very likely that someone else has already experienced the same issue. Check the following. Vendor knowledge bases. As users report problems, most vendors post resolutions on their websites. Product forums. You can communicate with other administrators in these forums to see if someone else has already dealt with the issue you are experiencing. Search engines. You can search for the symptoms or error messages you are seeing to identify a resolution to your issue. If your theory is not confirmed at this point, you need to do one of two things. Go back to the beginning of the troubleshooting model and reestablish a new theory, or escalate the problem to someone who has more experience. When escalating a problem, take the time to accurately describe the problem, identify the steps you've already taken, and explain why the problem is beyond your ability to fix. This will help the escalation engineer know where to start and what the cause might be. After determining the steps necessary to resolve the issue, you should next establish a plan of action to resolve the problem and account for any potential side effects. For example, you may determine that you could fix the problem right away, but doing so might require excessive network downtime. Downtime costs organizations money and is usually unacceptable. In this situation, you should consider delaying the fix or implementing a temporary fix and save the large fix for after hours when fewer users will be affected. You should also evaluate whether the fix requires managerial approval. For example, the solution may require expenditures for additional hardware, software, or professional services. At this point, you're finally ready to implement the solution. Once done, don't automatically assume that the system will work properly. You should implement a series of tests to verify full system functionality. As you go through this process, you may realize that the problem you just fixed could actually be prevented in the future if certain measures are taken. If this is the case, then implement the necessary preventative measures. At this point in the process, the problem is fixed, and many administrators assume they are done. This is not the case. Before moving on, there are still several key tasks that you need to complete. Communicate with the user who reported the problem to make sure they know how it has been fixed. Have the user verify that the problem truly no longer exists. If necessary, educate the user on measures they can take to prevent the problem from reoccurring. Document your findings, the actions you took, and the outcomes you observed. By doing so, if this problem reoccurs in the future, you'll already know how to fix it quickly without having to go through the entire process again. In summary, good troubleshooting requires knowledge, experience, and a lot of intuition. Following an organized troubleshooting procedure can help you gain experience and ensures that you follow a logical and organized approach. It may also reduce the amount of time that you spend in troubleshooting. The steps you should follow are: identify the problem, establish a theory of probable cause, test the theory to determine cause, establish a plan of action to resolve the problem and identify potential effects, implement the solution or escalate as necessary, verify full system functionality, and if applicable, implement preventative measures. Document findings, actions, and outcomes.